Good evening, and welcome to today's session to talk about Burstable, cost-effective performance T instances. My name is Meena Gowda.
You're live.
And well, that's a good wake-up call for everyone. So my name is Meena Gowda. I'm a senior product manager from Amazon EC2 business. I focus on Burstable instances. And I also have two guests, Ken, an architect from Trend Micro Japan, and Brian, who's a principal product manager from Amazon RDS, who will talk about their experience using T instances. So today's agenda, I'll be introducing the general purpose Burstable instances, how it works, how it's priced, what are the new advancements we've done in the latest generation. Then we'll have Ken come talk about their migration path coming to AWS and how they've been using Burstable instances. And then Brian will come talk to us about how RDS customers are benefiting from T instances. And then we'll also have a Q&A at the end. OK, let's kind of take a look at what Burstable instances are. So if you look at majority of the general purpose applications, I just want to understand how many of your applications or workloads have a continuous and fixed CPU usage? Does it look like this, or does it look like this? So chances are it's like the second picture. Most of the time, you have like a variable CPU usage, and there are periods of time where the CPU usage is kind of bursting to peaks, and then it quickly comes back down. Or there might be periods where it needs to sustain high CPU, and then it's just running at some kind of like a moderate CPU usage. So if you have a variable CPU usage, why should you pay for fixed CPU price when you can get the same performance at a lower price, like on the Burstable instances? So we did an analysis of the applications and instances that are running general purpose workloads, and we saw that majority of the general purpose instances use low CPU utilization, and only a fraction of the instances are using high CPU utilization. A broad set of general purpose workloads fall on the left side of the chart. So this really was the driver for us to come up with Burstable instances. So we developed a Burstable instance that is optimized for most general purpose workloads with occasional high CPU use. It also has the ability to sustain high CPU usage should the workload need it for whenever and for however long that instance needs it. By design, the instance is built to have a moderate CPU usage that is included as part of the base list price that you pay. But then if you want to sustain high CPU usage, you just pay like a pay-as-you-go on-demand price for that incremental CPU usage. So it's totally a variable usage, and you pay only for what you use. It's very much pay what you use for. So as we kind of continued on this journey, I want to show where we started this journey of building Burstable instances. Back in 2010, we launched our first generation Burstable instance in one size, just a T1 Micro, just to see how customers are reacting to it and how the product is working. And the T1 Micro was a well-received product for microservices, for hosting web servers, things like that. So as customers started to use the Burstable instances, they started asking us for Burstable instance in more sizes than just the Micro. So in 2014, we launched the next generation Burstable instances in 4 different sizes: the Micro, small, medium, and large. And along with that, we also designed a more transparent and traceable CPU credit model where you can see how you're earning CPU credits when you don't use the compute power, and then you use the earned CPU credits to burst compute power. As customers started using it, you asked for more sizes on both sides of the spectrum. So there was a nano size that we launched in 2015, and then we launched the extra large and 2 extra large sizes in 2016. So as customers started using the Burstable instances for majority of their workloads, general purpose workloads, we started to see some rough edges and use cases where it was having pain point for customers. For example, managing the credits was a challenge because the bursting mechanism was based on the CPU credits. There was some level of unpredictability in knowing when the instance will start throttling the workload and bring it back to baseline, thereby the application experiencing a bad deterioration. So with that feedback, we disrupted the market by launching this feature called Unlimited, which essentially makes it indistinguishable for you as customers and for your general purpose applications for running on burstable instances. So in the unlimited mode, you don't have to worry about CPU credits. You don't have to keep tab of them. Your application can use the compute resource it needs whenever and for as long as it needs without having to worry about credits. And then you asked us to launch that in the latest generation Intel processors. We went a step above and also gave you a new processor, AMD, which was announced earlier this month, or pre-announced earlier this month. It's coming soon. So we'll spend some time talking about T3 and T3A after this. So before we go into talking about T3, I just want to go over what type of workloads can benefit from burstable instances. It's good for workloads that don't need fixed CPU resources. It's good for application that occasionally needs quick access to high CPU. So the key thing that we wanted to make sure we got it right with the burstable instance is that the instance can react to very small spikes at the scale of microsecond granularity, because otherwise it really doesn't matter what we do with burstable instances. Instances that don't need or just need moderate CPU majority of the time, but also instances that need to sustain long periods of high CPU usage. So here are some examples of workloads that customers are using burstable instances for, and these customers have migrated a lot of their workloads from using M4s, M5s, and even some of the older generation C instances, and are benefiting from using burstable instances and getting the performance they need at a lower cost. So now let's look into the latest generation burstable instance. So T3 and T3A. T3 offers 30% better price to performance compared to the previous generation predecessor T2 instances. T3 is based on the Intel Xeon Platinum 8000 series Skylake processor with all-core turbo clock speed of 3.1 gigahertz per second. The AMD instance for Bustable is based on AMD EPYC 7000 series processor with an all-core turbo CPU clock speed of up to 2.5 gigahertz. We have enabled unlimited mode by default because this was a customer ask that we frequently heard, that using unlimited mode or switching to unlimited mode was becoming a challenge on T2 instances. So to make it easier for you to not worry about CPU credits, we're enabling this by default with the ability to switch to standard if you choose to. But we see like more than 95% of our customers are using unlimited mode. The T instances, the T3 generation instances come with twice the number of vCPU on the smaller instance sizes. If you recall, on T2, the nanos through small sizes had only one vCPU. By doubling the vCPU count, now you get twice the compute power on the smaller sizes as well. We have enabled hyperthreading by default, so you get the incremental performance that is enabled by the Intel processor chips. And it's built on the EC2's new AWS Nitro system, which gives you more access to the CPU power and higher network and storage performance. We also improved the network performance on T3 instances and T3A at 5 gigabits per second for burst. For EBS performance, you get up to 1.5 gigabits per second on the smaller instance sizes, up to 2.1 gigabits per second on the larger sizes, which is more than 2 times the performance you had on T2 instances. Just like on T2, T3 and T3A will be EBS storage only. We do not support local storage. So this is a comprehensive view of all the sizes that both T3 and T3A instance will be available. You can also see the CPU usage it is optimized for. So as you are familiar, we offer a linear pricing. So if your workload does not need the CPU, you can scale down to a smaller size that it's optimized for and benefit from the lower cost as well. T3 is available in almost all commercial regions except for Mumbai, which is coming soon. And then we're also launched it in the 2 GovCloud region recently. Let's take a look at the T3 pricing model. I'm sure this is something that's going in the back of your mind in terms of like, if it's going to be cheap, but then the variable CPU, how is it going to be priced? So right out of the bat, T3 is 13% cheaper than M5. You can do the math, 17% cheaper than M4, 10% cheaper than T2. It has 30% better price to performance compared to the previous generation T2 instances. T3A, we've further discounted the price because we're introducing a new processor. We want to welcome you to come try a new processor in the enterprise server market and give us your feedback. So we've discounted the price further. It's 10% cheaper than the already cheaper T3 instance. Then we have a CPU credit price, which is priced as 5 cents per vCPU hour on the Linux, Red Hat, and SUSE OS. And it's 9.6 cents per vCPU hour on the Windows OS. So similar to T2, T3, and T3A, the CPU price is the same. We have tried to keep it same so that it's easier for you to just keep track as 5 cents per vCPU hour. That's the only number you have to remember here. And it's the same across all pricing model. The CPU usage is tracked at a microsecond granularity at the CPU credit, which means that if your workload needs a very small spike, it can do so by using CPU credits and never have to pay any extra fee for the temporary spikes that you have. We calculate the average CPU over 24-hour rolling period. So as long as your spikes average out over a 24-hour period, you can benefit the burst performance by paying just the baseline price. So what happens when you do exceed that baseline performance? So if your instance, say for example here I have a T3 large showing, if it is performing at baseline, then it's already covered in the list price that you pay. But if the average CPU utilization for your workload is slightly above, like say at 40%, then you're only paying an incremental 10% on top of the base price, calculated by the 5 cents per vCPU hour that we listed out. So this is a table that gives you a comprehensive view of how many CPU credits each instance can earn per hour, and the maximum CPU credits an instance can earn. We kind of have a bucket model, which is as the instance is idle or just using moderate CPU, it will start accruing CPU credits, and then it can use that credit to burst at a later period of time. But because you cannot, you can't burst more than 100%, we have a bucket, which basically means that you can only earn so many number of credits for that particular instance size, and then after that, you don't accrue any more credits. So if you take a T3 2 extra large, for example, it's optimized for 40% or less CPU utilization. When your instance is running below 40%, it can earn up to 192 credits per hour, or a max of 4,600 per day. Now, with that 4,600 vCPU in a day, you could use those credits to burst roughly about 9 hours using all the 8 vCPUs for that instance. or if you spread it out over a 24-hour period, you get the 40% baseline CPU. So how this token bucket works, it's very simple. If an instance uses CPU below the baseline, then the bucket will fill up faster. So if your outflow rate is slower than the inflow rate, your bucket starts filling up. The opposite is true as well. If your outflow rate is higher than your inflow rate, then you start depleting credits from your bucket. If the outflow rate starts to reduce, then you'll see that your bucket starts filling up, and you'll see your accruing CPU credits. Now, this is an interesting one. If you run out of credits, and if your instance needs to burst, you can continue to do so, because in the unlimited mode, we do not throttle you, and you only get charged at the end of the month for the incremental CPU usage above the baseline. Now, if you don't want to deal with all this variable CPU price, no problem. You still have the standard mode available. You can switch to standard mode on T3, on T3A, and on T2. You're guaranteed to not pay any additional CPU usage when you operate in standard mode. However, you do want to know that when you run out of CPU credits, your instance will be throttled back to baseline, and you can burst only after accruing CPU credits. For all these instances, you can switch from standard mode to unlimited mode, from unlimited mode to standard mode. There are no restrictions on when and how you can do it. You can always do it anytime you choose to. Now, if you're wondering, how do I decide which of my general purpose workloads should I move to which T3 instance size? So I'm going to show an example of how to determine that break-even CPU usage threshold where you can confidently say that running on T3 will be cheaper than running on, say, M5. So this is a T3 large, for example, and has a baseline CPU of 30%. Now, if your instance is bursting at 100% throughout the time, then you will end up paying quite a lot on the T3 large, which will be roughly about 1.5 times the cost of running on M5 large. So for instances that do need fixed CPU usage, you're better off running them on M4s or M5s. But for instances that don't need the fixed CPU, and if the average CPU is somewhere like, say, 42.5%, you will pay exactly what you pay on M5 large on a T3 large. So this is the break-even price for a T3 large compared to an M5 large. And you can do this calculation for any other instance size as well. So if your average CPU is anywhere in that grid below the blue line, then you will be saving by running on T3 instances, still benefiting from the same performance you can get from an M4 or M5 instance. So your T3 will be cheaper than running on M5. And this is your back of the envelope calculation and how to figure out that break-even threshold. I've shown an example of how to do it for an M5 large. You can use the same thing for calculating an M4 or a C4 or C5 to figure out what is your average break-even threshold where T3 will make sense and cheaper to run on. So the calculation goes very simple. You look at column E. It's the price difference between T3 and M5. You divide that by the price per vCPU minute, which is column I. So I is the division of price, the difference between T3 and M5 divided by the charge per vCPU minute. It gives you the number of minutes that the instance can burst at 100% CPU. Now you take that 100% CPU and spread it out over a 60-minute period. It'll give you the incremental CPU above your baseline for which you can burst at the break-even price. So in this case, it is a 12.5% incremental CPU you get on top of the baseline 30%, giving you the break-even CPU as 42.5%. You take the same calculation and do it for all the other sizes. You'll see for T3 extra large, your break-even CPU is 52.5% compared to an M5 extra large, and the same thing for the 2 extra large compared to an M5 2 extra large as well. You can use this model for comparing with any other instance size as well to figure out if T3 will be cheaper. Now, how do you switch to T3? It's pretty straightforward. We do have one requirement. you need to have the right drivers to run on the new Nitro system that T3 runs on. So it needs the NVMe drivers installed, and it also needs the Elastic Network Adapter drivers installed. We do not support Classic Link on T3. We didn't support it on T2 either. So those are the prerequisites, and there are instructions on our public-facing user guide that shows how to install these, how to check if these drivers are installed in your armies, and if not, how to install them as well. There's a step-by-step guide. And once you are done with that, you can switch to T3 instances using the Amazon EC2 console or using the AWS command line interface. So if you pick the console route, you just go select the instances that you want to switch to T3. You stop the instance, then you go to instance setting, change instance type, and then you'll get a drop-down menu showing all the instances that this instance can migrate to. You pick T3 large or medium or whatever size that you want to, and then you restart the instance. It will be running as a T3 version. You can also use the console to switch from unlimited mode to standard mode if you don't want to use either of those modes, or you can switch and toggle with them whenever you choose to. You can also use the CLI to switch to unlimited mode or to switch to T3 instances. You can call the run API and define the attribute called CPU credit, and the value to define unlimited mode is unlimited or standard. You can modify an existing instance by calling the modify API, provide the instance ID, and then define the CPU credit attribute for that. If you want to find out what mode an instance is running on, you call the describe API, and then it will give you in what mode it is running in. T3 is supported across all major OS and all new version armies, just like every other latest generation instances. T3 does not run on PV and Amazon S3 backed armies. So that's it. Now I'm going to hand over to Ken to come talk about their migration to AWS and using Burstable instances.
Thank you. Good evening, everyone. My name is Ken Izawa. I'm a tech architect of Information Service Division of Trend Micro. Today, let me show you about our case studies of the using T3 instances. Okay, in 2017, it's last year, our team provided information services from our on-premise data center, and we managed 70 web applications for both internal and external customers. Then we also managed two more very important core systems, like ERP and commercial and customer databases. In total, we managed 70 servers in both development, staging, and production environments. Okay, let's move to the pain point. At that time, we had these three pain points. Let me explain to you one by one. Okay, the first one is we try to calculate the total cost of each services, but it's very difficult to do that. It is because we didn't have visibility system to show the detail of the costs in our located in local data center. Okay, the next one is in Japan. Sometimes we have a very big earthquake almost every year now. So it is very important to think about the business continuity planning and disaster recovery planning. So even our system is located in data center, on-premise data center, it's very difficult to complete it. That's the second pain point, and the last one is the managing the server is becoming a challenge and operational workload at that time. So our team decided to migrate our web service, all of our services onto the AWS environment. But at that time, our team doesn't have enough experience and enough knowledge for AWS services, so all we have to do is starting from the learning AWS services from scratch. And learning and designing and benchmarking and price calculating. Finally, we find that our goal should be to maximize cost saving across AWS services. And in EC2 part, we decided to choose EC2 instances as much as possible. And one more big EC2 advantage is T2 instance supports the smaller instance sizes than large instance, such as T2 medium, T2 small, and so on. So to think about the production environment, T instance worked great for production workload when CPU peaks were spikely and predictable. Very similar to the snapshot here. This is from one of our production web servers. And then to think about the staging and the development environment, majority of the use cases, except for the stress testing, is stress testing is a very important thing. We need to think about it. But except for the stress testing, it's very good. T2 works very fine for our development and staging environment. And the next, in order to monitor, we have to think about the CPU monitoring, CPU credit balance monitoring, in order to avoid sudden slowdown in our web applications. Okay. On the other hand, there are some cases not fit with T2 instances, such as a database server with high transactions. And also, when servers with scheduled tasks all over the night. These kind of instances, we shouldn't choose the T2 instance. We decided to use the Jazza instance types for this kind of usage. Okay, so finally, we have completed our systems migration onto the AWS environment, and the benefit is come like this. Now, it is very clear and predictable costs from AWS costs by using the AWS Cost Explorer. And for think about the BCP and DR planning, not all systems of us, but only in a limited important systems are already built up the BCP DR environment by using the AWS Oregon regions now. And now we can provide the very stable services now. So we hope, we think that our internal user and outside customer also think it very works fine. And then, let's think about the development environment. 100% of EC2 instances are based on the T2 now. And in staging, 94% of the instances are based on the T2. Even in the production, 86% of the instance is based on the T2 instance now. Okay, let's move to the next steps. So what we are thinking is to switch to T3 and T3A, because these are the next generation model of the T series, and it will give us additional cost savings. And also, we are thinking the instance consolidation to maximize the cost reduction. And of course, application also need to consolidate onto the T2 instances. That's what we want to do. And the last one is we want to use more reserved instance and spot instances. If we use this, we can get more cost reduction for us. It's very good. So these are the next steps for our thinking now. Okay, that's from me. That's all for me. Thank you so much. And
thank you, Ken. Hello, my name is Brian Welker. I'm a principal product manager on the Amazon RDS team. Work on both Amazon RDS and Amazon Aurora. And I'm going to talk today about why you might choose a T instance for your managed database workload. Now, some people will say that's crazy. We would never use a T for our database workloads. We would only use a big M or an R series. But it turns out that Ts actually make, for a lot of workloads, make a lot of sense. They'll save you money, and they perform just fine. We have lots of customers who are using Ts not only for development and tests, but also for production. And we're super excited about the recently released T3s. We think that it's going to become even more popular within Amazon RDS. Now, hopefully, everyone knows about Amazon RDS, but if you don't, there's a quick primer on what RDS is. The goal of RDS is to make it easy to run your relational database in the cloud. And we take care of things like setting up the database, configuring the operating system, configuring the database software, patching the software, setting up all the monitoring, supporting scalability, so scaling up both storage as well as scaling up the instance type. So that's all taken care of in Amazon RDS. And the other thing that we do in RDS is we provide a high availability solution. So even on the T-Series, with one click of the button in the AWS console, you can tell Amazon RDS to replicate all of your data to a second availability zone. And if anything happens, if we can't access the primary instance, we will fail over to the instance in the secondary and keep you going. Typically, setting up your own high availability takes a lot of work, and Amazon RDS makes that super easy. And RDS is secure by default. We have settings that support data encryption, both at rest as well as on the wire. And we comply with most of the industry compliance, so easy to get started. And you get to pick whatever database engine you want. So Amazon RDS has the same features for our cloud-native database, that's Amazon Aurora, for MySQL, for Postgres, for MariaDB, and if you're using a licensed database like Microsoft SQL Server or Oracle database. So the same environment, same set of features, supported across all of the database engines. Now, one of the things that when you go into RDS and you pick to create a database instance, you'll get to pick your instance type. So similar to EC2, now in RDS, we don't offer every single EC2 instance type. Turns out that databases generally like lots of memory. So we, for example, don't offer the C class, the C family in Amazon RDS. We generally offer the T series, so a Burstable general purpose, the M series, which is our general purpose, and then memory optimized, so for high memory. So for T, we think about that as sort of the smaller or variable application workloads. We'll talk a lot more about the T behavior for databases. In the M4, and recently we released M5 support. So that goes up to the M5 24 XL up to 96 vCPUs, 384 gig of RAM. It might be even higher than that. High performance networking. So this is really good if you're running a heavy duty CPU intensive workload. So if you're running a big WordPress site or you're running some other third-party software that needs lots of CPU, the M series is a great choice. And then for the R series, goes up to 768 gig of RAM. Really good for analytical workloads where you're doing larger queries, or if you've got a really high connection count. If you're putting thousands of connections against a database, you want a high memory configuration. And I'm going to focus on the T2 series, T2 and T3. So it turns out that while most databases, people create a lot of databases, it turns out that most databases really don't get run all the time. And for workloads that don't use the CPU all the time, which is most of them, the T2 and T3 are really great choices. Now, with T3 and with T3 Unlimited, you have the option to burst for higher CPU performance. So we still offer the same underlying burst credits. So great for if you want to spin up a database for test and development environments, you want to try something out. So really great for this series. Now, it turns out that most customers who are trying out RDS for the first time choose a T series because it is least expensive. It's also eligible, the T2 is eligible for the free tier, so if you want to get started in RDS and you want to just try it out, you can run a T2 Micro for a year for free. And with T2s, we offer the sort of classic mode, not unlimited. With T3s, we will be offering unlimited in Amazon RDS, so you do have the ability to go above your balance, your CPU balance, and then pay a little bit extra if you're using over your baseline. As Mina said, better price performance over T2, and we will support unlimited. So we think that T3 for many, many database applications, database workloads is going to be a great offering. We also recently, last year, offered the full X large, 2X large, so the upper end of the T's for larger workloads. So this is actually a graph. We did a fleet wide sweep and looked at all of the instances and looked at what they were actually using in CPU. So you see sort of the CPU utilization on the left side. It kind of peaks out at 100%. So this is sort of how much of the fleet is using 100% of the CPU versus how much of the fleet is using a lower percentage. And you can see there's a very small percentage of the fleet that is maxing out the CPU. That's in that 80, 90 max out range. The vast majority of the fleet, though, there's a very long tail, is using 10% of the CPU, 20%, 30%. So it turns out that even though databases are, you want your database to be available, you want it to be available all the time, it turns out that there's a lot of databases sitting idle in the fleet. And these are great candidates for using the T series. Now, if you've got a very consistent workload, so let's say you're looking in CloudWatch and you see your database is at 30% consistently for a 24-hour period or 40%, and you want to keep that, then you can certainly use an M or an R. But we think that most people, when they look at the actual usage, will be able to use a T series. And so with that, I'm going to turn it back over to Mina for a recap.
Thanks, Brian. All right, so let's recap and send you off to the reception for some happy hour quickly here. So the thing that I want you to walk away from here is that T3 is cheaper, 13% cheaper than M5 instances. It's got 30% better price to performance compared to the previous generation T2 instances. T3A has an additional 10% discount compared to T3. It is optimized for a broad set of general purpose workloads with the ability to burst for high and sustained CPU usage. There you go. And it is supported in all the different pricing models. On demand, 1 year, 3 year RI, standard and convertible, also in spot. So your call to action for today after the session is to go actually try out the T3 instances. If you are running general purpose workloads on M4s, M5s, C3, 4, 5s, whatnot, and you have less than fixed continuous CPU usage at the range of like 30, 40%, give T3 a shot, see if it meets your needs, and you can benefit from the great performance and lower price. So thank you. And we will take some Q&A now. We have a few minutes left. So I think the mic there is live, and if you can come up there. And you are also requested to complete the survey from your mobile device about this session. Thank you. Yes? We can save the applause for later, after the Q&A.
I was just actually curious about the T3A versus T3. If it's cheaper, why even release a T3? And what was the kind of thought behind the T3A?
Yeah, so the thought behind is AMD has been coming into the enterprise server space, and we are launching a new product. From a performance-wise, AMD is still able to offer the same performance as Intel. This particular processor that we chose has a slightly lower clock speed, which means that the measure of performance from the data that we use as backend is slightly lower than the Intel version. So in order to kind of match the same price to performance, we priced T3A cheaper than T3. So it still offers the same price to performance from a CPU performance standpoint. And also, it's something that we are introducing in the market for the first time. So we want to give our customers a chance to kind of give it a try and not be worried about the price standpoint. That's why T3 is priced cheaper.
So one other question. For the T2, I noticed that in your pricing data, it says that it uses an Intel Xeon family. Is there a consistent processor that the T2 uses, or is it just a Xeon?
Yeah, we have been using the Xeon processor family. T2 has a mixed fleet of Haswell processors and Broadwell. Our smaller sizes are based on Haswell processor, and then the larger sizes are based on Broadwell processor. I think the Broadwell processor is like the previous generation to Skylake, and then Haswell is like the one generation before that. So they're all on the Xeon processor. Yes?
Is there a matrix of all the instance types and their CPU thresholds for where a T instance would be more profitable or cost saving?
Yes.
We have to do all the math ourselves.
Yes, we do have product page for T2 and T3 where it lists out the CPU for it lists out the instances for on what CPU optimization it is built for. So if you look at T3 large, it is optimized for CPU usage of 30% or less. Extra large is for 40%. So you can go back to T2, we have the same information for those instances as well. Any other questions? Okay, I'm not going to hold you up from the happy hour. Enjoy. Thank you all for coming. Have a good evening.